Next, I'm going to talk about one of the tools that Amy, there's actually two tools that do the same thing, one for wood frame construction, the other for steel frame construction. And it's a wall calculator. You'll go to this when you click on the steel frame wall calculator, you'll go to this introductory page that gives you some background information, and then click here at the bottom and you'll go right into the tool. This tool is an online calculator that you can use to specify a code compliant wall assembly that does two things. It allows you to check for energy code compliance, and it also allows you to check at the same time for building code moisture control compliance, in particular how to arrange the use of a vapor retarder along with exterior insulation to basically keep the wall warm and dry and have drying potential so that if it does get wet by some other means that you would have sufficient drying capability in that wall assembly. The tool is based on research. You can click here for more information on the tool. For example, when checking the energy code compliance, there's a text you can toggle here that will tell you which parts of the code it's based on and complying with, and also even get into how the calculations are done. So the tool is fully transparent and consistent with the way the code was developed. In fact, I'm going to close that text out. The text on the vapor control check is consistent with the latest model building codes, the IBC, International Building Code, and the International Residential Code. The research that it was used to develop these tools is now also the basis of new provisions in the 2021 IBC and IRC. So in fact, we add these tools give you more flexibility because those codes are very prescriptive and limited in the solutions just to keep things simple in the code. But this tool allows you to explore a lot more possibilities in how you can design a wall assembly. Some background on some additional moisture control recommendations up here up front on the tool that you can read through here and find some additional things or best practices that are recommended to go above and beyond the code. And oftentimes these don't cost you anymore. They're just things that make your walls perform better, and we thought it would be useful information, whether you're using foam or not, actually, to have better wall assemblies. And also some text here on the whole idea of wetting and drying potential and the importance of keeping that in appropriate balance. But the tool will do all those things for you. So I'm going to jump into just a real quick example that's relevant to the Chicago area. And we'll just leave this here on, we'll assume the building's being designed to the 2015 IBC and the International Energy Conservation Code commercial building for buildings that are not Group R, they're not residential type buildings. Climate zone, we'll put in climate zone 5. You can also do it by heating degree days. That doesn't change your energy code requirements because that's still done by climate zone. But on the moisture check, it's quite precise in how to balance your exterior insulation amount to your interior insulation amount so that you keep that wall and what would be a condensation plane warm enough that it never sees doesn't see dew point and stays dry in the winter. And then it's a matter of specifying the vapor retarder on the interior side that allows that drying to the interior. And then you don't have to worry about even the sheathing permeance on the exterior or all of those things that in some cases are hard to find actual numbers because the materials aren't necessarily required to report their vapor permeance or their class or even a wet cup vapor permeance. And so this tool makes it a lot easier to do that, but you can put in your heating degree day and get a more precise answer for that water control. And sometimes that'll make a difference if you're at the southern end of a climate zone versus the northern end, and it'll help you really fine tune your designs to exactly where you're building if you want to. At this point, we'll just leave it at climate zone 5. Exterior cladding, right now the default input is stucco. It's got the lowest R value, that's why it's the default. But let's say you're using brick, so we'll pick brick for the building wall. And let's say for exterior insulation, we're going to put in let's put in just R9 for sake of example. And you can see up here on the energy code output check on the right side, it's already telling us what the code requirement is. R7.5 CI, or continuous insulation, is required. We put in R9. The cavity insulation requirement along with that is R13, but we haven't input that yet, so we have a fail on our energy code check. And this updates as you do your inputs. Now, because we have all exterior insulation, and it's sort of the perfect wall, you've got all the interior parts of your wall, the structure is connected to the interior of the building. You don't even need a vapor retarder, but it wouldn't meet the energy code. So we would either need to increase the CI amount to meet the energy code, or put in some cavity insulation. So we'll put in some cavity insulation. Let's say we're doing a 6-inch steel stud wall. We've got them at 16 inches on center. That might be something you see on the second, third, or maybe even fourth story of the lower stories of a steel frame building. Cavity insulation, now it tells you how much you can put in there based on the calculation procedure, which adjusts the performance of the cavity insulation for the thermal bridge that's created by the steel. So the cavity insulation, you don't get full credit because of the thermal bridging, whereas continuous insulation, you do get full credit for its R value. And this also is consistent with the calculation procedures in the International Energy Conservation Code. So we'll put in R21 here for sake of just having a number. Obviously, this is above code, so we would expect it would pass the prescriptive provisions of the code, and as well the U factor check. You can use either one of these to do your design. In fact, what we can do is we can look at, well, let's say we wanted to use a 4-inch or thick steel stud wall instead of 6-inch. We'll take a look at that. You can see with this insulation arrangement, the amount of exterior continuous insulation versus interior, that the tool is recommending that a class 1 or class 2 vapor retarder would be needed to make this work. You can't just rely on a class 3, which is like your interior latex paint. In the wintertime, that would not control the flow of vapor into the assembly sufficiently, even though the continuous insulation is keeping it warm. Now, if we add more continuous insulation, the more we can open up that interior side. Before we start to do that, as an option, when you do use a class 1 or 2 vapor retarder, these notes are very important, these footnotes. They need to be smart, or what the newer codes are going to call responsive vapor retarders. So like a class 2 smart vapor retarder would be your traditional craft paper. It's a class 2 vapor retarder, but it's also one that happens to have smart vapor retarder properties, being craft paper, coated craft paper. As the humidity starts to raise and you need to have drying to the interior, say in the spring and summer months, that product naturally opens up and lets the vapor flow out of the assembly and drying occur. So that is a smart vapor retarder. If you're using a class 1, you wouldn't be able to use something like poly. You would need to use more than likely some type of a proprietary film, and there's several types that you could use that would meet that requirement. But let's go down and let's try to say, well, we would like to use a class 3 or maybe even no vapor retarder, have the perfect wall. So we can rearrange this assembly, and just for sake of example, I'm going to change the stud thickness to 3.625, which is a common 4-inch nominal steel stud. We can see now it's like, whoops, you can't put that much cavity insulation in there with the calculation procedure. So we'll change this to 13. And now we've also changed the insulation ratio. We've got more continuous relative to the cavity insulation, so that cavity is going to stay warmer as a result of that. Now you can see the class 3 vapor retarder will work. So we don't need to use craft paper. We could, it's smart. We could still use a class 1 smart vapor retarder, but why not just use, at this point, latex paint? A class 3 vapor retarder would pass and be consistent with code. We can see this assembly being slightly better than an R13 plus 7.5. Prescriptive solution passes both the prescriptive path as well as the U-factor path. In fact, it passes it quite considerably. So we could reduce the CI thickness a little bit if you wanted to. This tool would allow you to play around with that. But it still won't allow you to do the so-called perfect wall, where there's no requirement for an interior vapor retarder. And in that application, the foam sheathing can serve as your exterior vapor control layer, as well as your insulation layer, and as we'll look at shortly, your water resistant barrier layer, as well as your air barrier layer if you want to. Or you could combine other materials to have some of those functions. It's really up to how you want to specify the wall, but foam sheathing would allow all of those functions to be handled with the one product. So if we wanted to turn this wall into the perfect wall, then what we would want to do first is look at a solution of increasing the exterior insulation so that we don't need to have an interior vapor retarder. So I increased that to 15. Just for the sake of example here. So still the none is failing. We don't quite meet the insulation ratio required. So we need to decrease the interior a little bit more. So let's go to R11. And now it's almost there. We have an insulation ratio of 1.36 in our proposed wall, but we need to get to 1.4 to be code compliant. So if we were to just say, well, let's just leave the cavity empty and just have the exterior insulation of R15, then yes, that will work with having no interior vapor retarder. The exterior layers then would be specified to provide your vapor resistance as well as all of your thermal resistance. You can see here it's saying at the energy code check, you failed the prescriptive solution. The prescriptive solutions in the code don't give you an R15 CI exterior only insulation option. So it's showing it just doesn't meet what the code gives us, the 1 or 2 limited options that are in the code. But if you look at the U factor comparison, you're well above code or below the code U factor. So you've got performance that's better than the code minimum with that assembly. What that's telling you is that, well, you could reduce that a little bit and still be code compliant. So let's put in just R12 on the outside. I wouldn't necessarily recommend going code minimum, but you can see the R12 then gets you right at the code minimum. And you're still, because it's all exterior insulation, you're still meeting the ability to not have any interior vapor retarder. So this tool allows you to explore various options for your wall assembly and coordinate energy code compliance and also vapor control and moisture control compliance with the building code, or to exceed them if you want to. Finally, to mention the way to document what you've done, and let's say this is the wall that I want, then I can get a downloadable PDF just by clicking that button on the right. It shows up on the bottom of my screen. I open that up, and it should populate itself here shortly. And you can see is a report that shows what the code was, the date you did this analysis, your climate zone. It tells you, it shows you the energy code check. While it's saying the prescriptive path was not satisfied, it's only because you exceeded the 1 or 2 options that they had. But your U factor is showing that it satisfies the code. If you were better than code, it would actually show you the percent better than code that your wall satisfies. Because we went with the perfect wall solution with all exterior insulation in this case, we have all vapor retarder options available. And of course, if we picked the none, then we would have the absolute most drying potential. And that's shown here in green. if any of the vapor retarders don't pass, they'll show up in red. And so you'll have a complete documentation of your wall assembly down below that. And then this can be something that you can use to submit as documentation of the wall design is complying with the code in terms of energy code requirements and the building code vapor control checks. The back side of this page, or page 2, is much of the background information on the tool, so it's transparent what it's based on and why it can be considered compliant with the code, and repeats some of those recommendations I mentioned in the toggle text on the tool.